So I'm really glad you guys showed up today because probably of all of the review days today, confidence intervals and significance testing is what you're mostly going to see on that 2-question exam coming up. My guess is because half of the year is inference and significance testing, those 2 questions will have to involve some of that. So this is where we are. We've done the first 6 topics, and we're not doing the 8th topic because that has to do with chi-square testing and inference for slope, and they have thrown those 2 sections out. So let me show you. Somebody had a really cool, let me copy of this first before I do. A really cool graphic that shows how you figure out what you're doing. So if you want to know, okay, which inference test am I going to make? Well, the first thing is if you see a question that has a mini tab output, then that's going to be the linear regression. And we've already done linear regression when we did topic 3. So if you see a mini tab output, and you know what that looks like. It looks like constant, slope, the y-hat, the standard error of the x, and the standard error of the y's. And remember, we did a prediction equation like fat hat equals, I should say equals, something plus some number times the slope times some other variable. So that's when you would do regression analysis. If you see a table of frequencies, that would be the chi-squared testing, but because that's not on the test, we're not even going to worry about that. So the table of frequencies would be something like how many people who took this drug got better, how many people who took this drug didn't. So it's frequencies is the number. It's like a 2-way table. So then if you're not seeing the frequencies, which you won't on this test, you're going to either have a proportions test or a means test. And the proportions are, let's say you have 450 out of 532 people say brand X is their favorite brand, then that would be a proportion inference test. But if you had something that you can measure in units, for instance, average height or average length or average miles per gallon, then that's going to be a means test. And then depending on how many different samples, if you have 1 sample, you do a 1 prop Z. If you have 2 samples, you do a 2 prop Z. If you have 1 sample with means, you do a 1 mean t-test and a 2 mean t-test for 2 samples. So I got this from StatsMedic and I thought it was really cool. So I wanted to just show you, this is how you figure out what to do on the question. So mini tab, you're going straight to regression. If you have proportions or means, you're going to do inference tests for a 1 or 2 prop or 1 or 2 mean. Okay, don't forget your type 1 and type 2 errors. Type 1 is basically a false positive. It's when you reject the null, when the null should not have been rejected. And type 2 is when you fail to reject the null when you should have rejected it. So that's a false negative. So type 1 is false positive, type 2 is false negative. And you can read through all this. I'm not going to go over it with you because I think you guys pretty much understand type 1 and 2s. Oh, and by the way, you're allowed to have your notes with you on the test. So if you want to get all the notes that we've used for the review days, you can have this stuff in case you forget what type 1 and type 2 errors are. The only thing on this page, and this has a lot to do with the College Board questions I'm going to ask you today, is that if you have a p-value, your p-value is basically saying that's the probability. Let's say your p-value is 0.002. That's the probability that you would get that observed statistic. That's either your z-score or your t-test score, if the null hypothesis were true. And you're going to see about 5 questions today that have to do with this. It's the probability that you got a statistic at least this extreme if the null were true. And then phantoms is really important for your inference testing. So I don't think they're going to make you do phantoms, but the whole thing, because you won't have to find the test statistic or obtain the p-value, they'll have to give it to you since we're not using calculators. But they may ask you about the hypothesis, the assumptions, which test you would do, and to make decisions and state conclusions. So I'm not really sure how they'll ask, but we'll work on some problems where you would do them without a calculator. This is way back when we did our very first inference test. We talked about smoke alarms. So this report says that at least 90% of all American homes have at least one smoke detector. And so this city said, hey, we really believe that we exceed that 90%. We really think the people in our city are doing much better. So they took a poll of 400 randomly selected homes, and they found 376 had smoke detectors. And then they want to know, is this strong evidence? If they ever ask you, is it strong evidence, you're doing a significance test. So the parameter of interest is, are there at least 90% of the homes in this city with smoke detectors? And so the hypothesis would be P equals 90 for the H naught or the null. And the alternative would be P is greater than 0.90. So, and then your P hat is 376. It's the actual numbers in your sample. It's 376 had it, over 400 were sampled. So that's a 0.94. And your N is 400. So remember your assumptions. There's always 4 assumptions for inference tests. Random independent and the 10% condition are across the board for all inference tests. NP is when you have a proportion. So you need the NP numbers and the NQ numbers to be greater than or equal to 10. Well, NP is the successful, so that's 376. So all the rest of them are non-successfuls. The other 24 are NQ, and that's both of those are greater than or equal to 10. So always know your assumptions, because my guess is they will ask you those. And of course, because it's a proportion and not a means test, we're doing a 1 prop Z test. Here's how you calculate the statistic, and I don't think you'll have to because you don't have a calculator necessary for the test, but I got a Z of 2.6 repeating. And so if we're saying, are there higher than usual, or are they greater than, we're on the upper tail of this test. So we're saying this is the p-value area we need to find. So for a test statistic of 2.6 repeating, I went in and I did a normal CDF, and I got 0.0039 is my p-value. And obviously for a significance level of 0.05, that's way below 0.05. So since the p is low, we're going to reject the null and say, and remember, this is so important. Your conclusion must be in context. Don't just say, we reject the null because our p is low, because that could work for any problem. You have to actually talk about what this particular problem was on. So I said, here's my p-value. Oh, here's how I found it. I used a normal CDF. I did the mean for the sample, and I went up to infinity, essentially. And then I did the p naught, or the p for the population. We believe it's 90%. And then the standard deviation I found using p naught q naught over n square rooted. So they would have to give you those numbers. So here is the conclusion in context. Because the p-value equaled 0.0038 and it's very small, it is unlikely the observed results are due to sampling error. There is strong evidence that in this city, remember we're talking about a particular city, more than 90% of homes have at least one smoke detector. So they're rejecting the null because the p is low and saying, no, this city's homes have more than 90% smoke detectors. And then here's what you would say. You would say this p-value 0.0038 is the probability that if the null were true, if homes had a 0.90 rate of using smoke detectors, we would get this probability that that would be true for this particular city. And since that's so low, we can reject it and say, no, that probability is way too low for that to be true. So we believe that the homes have much higher rates. I showed you how to do it in the calculator, but I don't know why I would need to do it now, because we're not going to use calculators on this test. And then the 95% confidence interval, remember it's p hat, which was 0.94. That was the 376 over 400, plus or minus your z critical. For 95%, it's 196, times the square root of, we don't use p naught in confidence intervals. We actually use the hat. So that would be 94 and 06 over 400. And so we get between 0.916% and, well, 91.6% and 96.3%. And we can see right here that 90 is not in this interval, it's on this side of it. So since every one of these numbers is above 0.90, we would say we are 95% confident that the true proportion of homes in this city with at least one smoke detector is in this interval. And because it's greater than 90% in all cases, we were correct when we rejected the null hypothesis. So that is confidence intervals and 1 prop Z test for a proportion. That was half a year of inference right there in that problem. Are you guys cool with that?
Yep.
Okay. All right, good. Okay, so what type of error might we have made? Remember, if you reject the null, then that's a type 1 error. If you fail to reject the null, if your final conclusion is we did not reject the null, we failed to reject it, then that's a type 2 error. So since we did reject the null, we may have made a type 1 error saying that in this city, more than 90% of the homes have at least one smoke detector, when in fact, not more than 90% of the homes have at least one smoke detector. A type 2 error would be if we failed to reject the null and said only 90% of the city had at least one smoke detector, when in fact more than 90% did. All right, I'm going to skip these because this is just more of the same. I don't want to inundate you. And then when we did the means or the t-tests, that was for samples where you had a y-bar where it was some value that could have units on it. The first three conditions, independence, random, and 10%, have to be true also. But because we don't have NP and NQ, since it's not a sample proportion, it's a means, we do the nearly normal condition. So you really need to see some kind of histogram or curve of the data to make sure that it's not skewed left or skewed, well, that was a skewed right, or skewed left. I still can't draw skewed left. Or even unimodal. You don't want that. You want it to be a nearly normal condition where it looks like a normal bell-shaped curve. And again, here's the formulas, but I don't think you're going to need to crunch any numbers, so I don't want to spend too much time on those. Don't forget your standard error is the standard deviation of the square root of your sample size. And this part of it is anything after the plus or minus sign in both your confidence intervals is called the margin of error, and the y bar or the p hat is the average of the sample. Okay, and then so here's an example of means. So here we're saying a coffee machine dispenses coffee into paper cups, and it's supposed to be 10 ounces. So you know right off it's a means because that's a unit. So instead of saying a proportion, 376 out of 400 people, we're saying 10 ounces. So we know we're dealing with means. And that makes our mu not 10, because if we're expecting it to be 10, then that's what mu should be. And they're saying, okay, well, here's how many ounces 20 random cups gave us. So let's see if they're actually shortchanging. Do you think that this histogram looks nearly normal?
Yeah.
Yeah, I do too. That's pretty good. So that's the fourth requirement. Phantom is a machine pouring 10 cups of coffee. That's the parameter of interest. The hypothesis, H naught is mu equals 10 ounces. Alternative is mu is less than 10 because they think it's shortchanging customers, which would be on the underside. Here is the nearly normal. So there's my nearly normal right there. It's random, it was stated, independent. One coffee cup should not depend on another coffee cup's measurements. 20 cups is less than 10% of all cups of coffee this machine pours. And we're going to do a one-tail t-test because it's a sample mean, not a sample proportion. So again, here's the calculations, and they'll be able to give you this. They'll tell you what the t-statistic is or what the p-value is. And we can see right off that p-value is super low because it's got 2 zeros before you even come to a number. And most of our significance levels we check are against 0.05. So because this p is low, we're rejecting the null and saying there is strong evidence at the 5% significance level to suggest that the true mean of the amount of, move this over so I can see, coffee poured by this machine is less than 10 ounces per cup. So that's in context. We're talking coffee, we're talking ounces per cup, we're talking our significance level. We mentioned everything. We didn't just say we reject the null because the p was low. If you do that, I guarantee you, you're not going to get enough points to pass that question. So make sure you mention what the whole problem is. If it's about coffee cups, talk coffee cups. If it's about smoke detectors, talk smoke detectors. Okay, and then for the significance or the confidence interval, remember you had to find what the T critical was for 95% based on the number you had in the sample. They're not going to make you calculate this, but remember that it's not the same as the Z critical. When you do T critical, it actually depends on the sample size. So we use the inverse T thing to get that, but they'll have to give it to you. And then if your numbers come out to be 9.75 and 9.9, you can see that 10 ounces is not in this interval. Both these numbers are below 10, the high and the low number. So we could say we're 95% confident that the true mean of coffee poured by this machine is between these two numbers, indicating that it is pouring us less than 10 ounces per cup. So let me go over confidence intervals again. Okay, so for confidence intervals, here's what 95% means. It means if you take samples of the same size, 20 random samples, and you got their averages, 19 of those would somehow contain the true proportion, and one of those would not. Okay? So 19 in a 95% confidence interval, one should not, and the other 19 should. And if you look here, it looks like two didn't. So this would be 90%, right? Okay. Wow, I flew through that. I did not realize I can't remember how many questions there are. I think there's like 26, 27, I'm not sure. But they're on confidence intervals and significance tests. And remember, if you haven't done the demo test, did you guys get, well, you can do the demo test with just the testing guides number. Please try the demo test, because what they're saying is many of you may be using a device that doesn't work with their software. And if you run the demo test at home, I know I did it for everybody so we could see how it's done, but I'm using my MacBook. And that doesn't necessarily mean that's what you'll be using. So they want every one of you to run the demo test at cb.org/AP demo, and make sure that you can actually get to the demo, find the timer running, upload some weird document, and see if it works for you. So I emailed Dr. Grove and asked her to print everything for you guys. That's the testing guide checklist, the formula sheet for just the 2020 test. It's a very special formula sheet. So even though I gave you one at the beginning of the year, it's different because this test is an at-home test. And then there was a third thing I asked her to print for you. I forget what it was. The checklist. I forget. There was a third thing, and she said she's going to print it for all 9 of you taking the test and email it or mail it to you by postal service. So please be looking for that in the near future and make sure you keep it with you. And I know, Morgan, I think you said you had a printer, so I appreciate that, but I was hoping that she could do it for everybody regardless, so you would all have the same documents in front of you with all the same look. So let me know if you don't get those within the next week, because I told her your test is on the 22nd, and I want to make sure she knew that that was time critical. And then Stats Medic videos. I don't know if you guys are watching these. I am a huge fan of one of the guys. His name is Luke Wilcox, and he does some of these. So if you look, they did confidence intervals for proportions, significance tests for proportions, confidence intervals for means, and significance tests for means, and type 1 and 2 errors, all on these days, the 6th, 7th, 8th, 9th, and 10th. So I'm going to put this link, and if you want to go, each one of these is a 45 to 50-minute video, so it takes a while. Sometimes they go over homework, sometimes they talk. If it's Luke Wilcox, he goes right through it. He goes real quick. If it's the other guy, I forget his name, he's a little bit on the slower side, but they're both excellent. And I can't tell you how much I'm learning from these guys. So I highly recommend, I know I don't have the time to do all this stuff myself, but I highly recommend, and you can download their worksheets too. So I would do those guys as well. The Stats Medic videos are some of the best reviews I think I have ever seen online. And then again, those YouTube videos, I've already sent this link in the last days, so I'm not going to do it again, but I think these YouTube videos are also really good as far as the mechanics of the test. What should I expect? How should I prep for it? What should I do to get ready? So these YouTube videos on the test itself are really cool. So that's all I have. Let me open up all the faces again. So let me go one at a time. Brandy, you're unmuted. Is there anything that you have any questions on? Okay, you're doing a really good job of keeping up, Brandy. I've noticed that you've been right on the spot. How about you, Lauren? Are you good?
Yeah, I'm good, but just I don't think I finished the one that was due, the AP College Board thing that was due on Sunday. I don't think I finished that, but I can't go back into it because it's like locked.
Okay. Was that on binomials or probability? It was binomials, right?
I think it was binomials, yeah.
Okay, let me open up the binomials and let me make a note. I'll open up it again for a few more days. Is that it?
Okay. Yeah, that's all.
Okay. Morgan, how about you? You got anything for me?
No, I'm good.
Okay. And Jake the Snake, how about you?
I'm good, but I think I have the same thing as Lauren. I need to finish that.
Okay,
one.
so if I open it like in the next 3 minutes, you guys should both be able to go in. So of everybody here, I think Lauren, you're not taking the test. You didn't sign up in time, right? And the rest of you are, correct? Okay, so this is the last day I'm reviewing all the stuff that we've done, and we're going to start just working questions that are non-calculator based from here on out. So everything we do from here on out would be, here's what they think, the experts. These are not my questions. These are the ones the experts think they might ask this or they might ask that. And again, those stats medic videos, they go through some really fantastic examples of how they could ask you statistics questions and never have you touch a calculator. So it's well worth it. I know it's 45 minutes a lesson, and I know you guys have a whole lot of other things that are on your mind right now, but I personally love these sessions. And if you watch just one, you'll be amazed at how intricately they discuss the details of the statistics. They do a really great job. So if you can, go to these Stats Medic guys, because they're fantastic. All right, guys, that's all I have. You have the College Board stuff. I think I'm going to do a quizzes for sure, so I should add that in here. Quizzes on inference. And again, when you have a quizzes, I just take how many you get correct and add those points. I don't need you guys to upload your work or anything. So I'm giving you credit for doing the 26 questions on confidence intervals, and you'll get the points for the quizzes. And then please do the rest of this on your own, because I know it's a lot, but your year is about to end on May 22nd. Really, essentially, after that's over, the rest of it is a cakewalk. So let's really push to get all this stuff done before the 22nd. And that's only, today's the 4th, that's only 18 days from now. So that's where I am. So if we're good, I'm going to bid you adieu.
Bye, Miss Honorella.
Bye.
Bye, guys.